All right, we'll go ahead and get started with our lesson today. It's kind of covering two lessons in one. So 3.1 and 3.2, solving systems of equations. Want to talk about what that means real quick. So the definition for a system of equations would mean that there are two or more equations. We will only deal with two equations. In here, you can look into more problems in your book and they'll deal with three. It's similar, but just a lot more work. So you're welcome. All right, we'll have to find solutions to a system. Which that's always going to be an ordered pair or a point with, an x, y coordinate point, if you're not familiar with ordered pair. That satisfies both equations. Okay, so there's three different ways that we're going to solve systems of equations. The first one we're going to do by graphing. And when you're solving it, you will want graph paper. But we're only going to do one problem, and I'll show you this one quick without graph paper just to kind of remind you. And then I'm going to pull up what it's going to look like in your homework to graph in the Math Excel program. And so all the problems you do in Math Excel, you won't need graph paper for. So just bear with me on this first one. I think we'll be okay without the graph paper, okay? Because it's just one problem. So we'll talk about solving by graphing. So whenever you have to solve by graphing in your homework, you are always going to be given the grid with graph paper. All right, so I've got y equals x plus 2 is one of my equations. The other is 2x plus y equals 5. All right, so my two equations will have to have two variables, and they will be the same variables in each so that we can solve. So we'll have to figure out what x and y value would make both true. All right, we'll look at it algebraically in a moment, but graphing. So if you have lined paper, this really isn't going to be that bad. If you don't have lined papers like me, it's going to look worse. But some reminders on how we graph. So we're coming back to, these are lines, and I want them in slope-intercept form. Probably be the fastest way for me to graph, right? Your M, if you remember, is your slope. Your y-intercept is your B, right? You graph the y-intercept first where it crosses the y-axis, then you use your slope M to get to the next point. All right, so quick refresher on graphing lines. Maybe it's been a while. All right, so 2 is my y-intercept, that would be my B. So I am crossing the y-axis at 2. All right, if you have lined paper, just go ahead and use each line can be like where my marks are. Okay, I also have my slope is 1. So if you think back to M was rise over run, or think of it as a fraction. So I'm rising up 1, right 1 each time. All right, so when you have graph paper, so much easier to see than what I'm gonna do at the moment. But just, so from here I rise up 1, right 1. Up 1, right 1. I need to look at it straight on. All right, let me make that line. Okay, we may need more points because what I'm trying to find is the same x and y for both lines. So that means I need to find the point where they cross. So I might need more points. If I had the grid paper, I just put out a lot of points and draw my line. I'm just going to wait a second and then work with the second equation here. This one is not in slope-intercept form because the y is not by itself. So I'm going to go ahead and subtract 2x over. So now I have y equals You can write it as 5 minus 2x, or you could write negative 2x plus 5. I don't care which way you'd write it, as long as you know 5 is your y-intercept and negative 2 is your slope. All right, so now I need to cross the y-axis at 5. So 1, 2, 3, 4. I need one more spot up here. At 5. My slope is negative 2. All right, so if I think of rise over run, that as a fraction, a negative will move in the down direction. And then this is a plus 1, so then I will go right 1 each time to get to a new point. All right, so if I go down 2, right 1, I've already matched up where those are crossing. All right, that's the whole point of what I'm doing. So I'm just going to go ahead, draw in my lines. And this point right here is the one I was trying to find. All right, pretty easy to find when you have a grid in front of you. You will have that for all of your homework. Okay. All right, so we solved the system. We found the point that satisfies this. So the point, the x would be 1, your y is 3. So we write our answer as an ordered pair. All right, make sure in Math Excel you're putting parentheses, make sure you're putting the comma in between. It's going to be picky about setting that up correctly. Okay, you can test and make sure that this works. If I take and go back to the original problem and I replace the y with 3 and the x with 1, 1 plus 2 does equal 3. Great, that means that point works. If I test the second equation and I take 2 times 1 is 2 plus my y is 3, that does equal 5. We're good. Okay? So graphing is a nice visual to understand what's happening. Graphing sometimes will take more time than when we get to solving algebraically. And if you have a messy answer, something that a whole number here or an integer, then graphing is not very useful because we can't tell exactly where it's landing. So not every problem is good for graphing. So we need to have other methods as well. We'll get to those, but I do want to show you what it's going to look like on Math Excel. In that orientation assignment that you had, on the first day we were in class, I believe it had you practice graphing lines, but just want to make sure you understand how to do this so that it doesn't take you too long to do your homework. So I pulled up, this should be a similar one on the first question on your homework here. You can enlarge the graph if you need to. It says click to enlarge the graph as well. I don't know if it gets any bigger than what I have. We'll find out. Not much. All right, so I have these tools over here. If we're making a line, you need to use the line tool, and then I graph it in the same way. So I've got x plus 3 here. So 3 is my y-intercept. So I click and I have a point, and now I can move my mouse around and make lines. All right, so I know my slope is a positive 1. So I got to make sure I line it up, or I can just put the next point. And now when I have 2 points, it makes a line. Okay, if I want another line, I will click line, and now it's saved my first line. So I'm going back to over here. I have that negative x minus 3. So negative 3 is my y-intercept. I need to go down 1, right 1. So I set another point. Great. Save. Let's see if I have it lined up good enough. Excellent. Oh, good. All right, so then I put my ordered pair right here for my solution. All right, I need to put parentheses. So this is negative 3, 0. Oops. Check my answer. Okay, so make sure you set these 2 points that would be on your line, and then do each line, check it, type your ordered pair with parentheses. Okay? All right. We'll go back to our notes here. And we'll start solving algebraically. All right, so we've got solving by substitution. Okay, so I've got x minus y equals 12, and 2x plus 3y equals -1. All right, so solving with substitution, things that you want is you want a variable completely by itself. All right, so we'll need to get one variable alone. If a variable is already alone, that step's already taken care of for you. If it's not and you choose to solve with this substitution method, then you will have to get one of them alone. So you want to take a look at the two equations that we got and think about, is there one that's easier to get either x or y by itself that I don't have to take as many steps for? Probably the easiest variable to get alone will be this x. Is that the only one that you have to do? No, but all I have to do is add y to the other side, and then I will have that variable alone. So I'll rewrite that as x equals, I can't actually add y to 12 because they are not like terms, so I'll just write 12 plus y. So it represents the same equation as what I had started, it's just in a new form. And the reason why that will be helpful is now I have what x equals. If I knew what y was, I could say x is this number, but I don't. So now I'm going to use substitution, and I'm going to replace the x in my second equation with what x is equal to, which is 12 plus y. So instead of, I'm going to rewrite that bottom equation there. Instead of x, I'm plugging in 12 plus y. Now I have an equation that has the same exact variable. It has y, so now I will be able to solve for y. You should have done this before in some algebra classes, but maybe it's been a little while. All right, so I'll go ahead and distribute. So 24 plus 2y plus 3y equals -1. Combine by like terms of 2y and 3y to get 5y. Subtract 24. So I will have 5y equals -25. Divide both sides by 5. So y equals -5. Okay, remember your answer is going to be written as that ordered pair, because if I was graphing this, I'm trying to find the place where they're crossing. So when I write that final answer, my y value is -5, but I still need the x value. All right, so I'm going to take my -5 for y, and I'm going to go back to my equations from the start, and I'm going to plug in -5 in place of the y. You can use this equation, or this equation. All right. If I did substitution, I typically plug it in right here, because then I'd have x equals 12 plus a -5, so I know x is 7. All right, it'll work in any of the equations, but that one's one I can kind of quick do in my head. And then I've got my solution. Okay. There's a second method that we could do for algebra, or to solve it algebraically, and that is solving by elimination. For this example, I'm going to have 3x plus 3y equals 4, and 2x plus y equals 2. And we can go to lunch. Okay, and we are back. So we're going to be solving this problem by elimination. So in order to do elimination, I need to have all of my variables in line with each other. So right now this is set up well for elimination. I have my x's are lined up, my y's are lined up, and it is equal to my constant or the number that's all lined up. All right, so I'm going to try to add my equations together, but I want to add them together to eliminate a variable. All right, so if I add them right now, vertically up and down with those like terms, I will not be able to eliminate anything. So I'm going to have to multiply an equation by a number so that I would be able to eliminate at least one of my variables. So when I have a variable that doesn't have a coefficient in front of it, that's going to be kind of my best choice to try to eliminate the y's, because if I multiply that second equation by -3, I will now have a -3 in front of this y that would cancel with the positive 3y up top. All right, so I'm going to go ahead and rewrite that first equation down again. So 3x plus 3y equals 4. And then I'm going to write the second equation when I multiply all of those terms by -3. So I've got -6x minus 3y equals -6. So when I multiply every single term by my -3, it keeps the value of the equation the same. I just made all the numbers 3 times bigger. Okay, so now I'm kind of doing a little addition problem. I'm adding these vertically up and down. So I've got 3x minus 6x for -3x. Those would cancel out. And then 4 plus a -6 would be -2. And now I'm left with just one variable. So then I can go ahead and divide each by -3. So now my final answer would be, well, not my final answer, my final answer for x would be a positive 2/3. So this would be a case where it would not be a good thing to use a graph. All right. I'm going to pause this a second. Resume. Hide. Okay, so now I need to go back and solve for y. Now that I have 2/3, I'm going to put it back into one of those two equations in place of the x. It doesn't matter which one. If I were you, I would do the first equation because it will be easier to plug in a 2/3 when I'm multiplying it by 3. So plus 3y equals 4. All right, 3 and 3 would divide each other, so that's just 2. So 2 plus 3y would equal 4. I'm solving for y. And then once again, y will actually be the same as x. It is 2/3. So we would not want to graph this one, because that would be challenging to figure out where 2/3 was at. Okay. All right, I want to look at 2 more problems because there's kind of some goofy situations that can occur where we don't just get a nice point. So we'll look at 2 more examples here. So we'll just say solve algebraically. Some of your homework will tell you to use algebraically a certain method. If it says solve by graphing, you obviously have to type in or put in the graph and draw in the lines. If it says to solve by substitution, you can go ahead and use that suggestion, but you wouldn't necessarily have to solve by substitution. I wouldn't know. Okay? There'll be better times than others to use substitution, better times than others to use elimination. So I'm going to put these two problems up here. So I'll put two examples up. And this first one is y equals 6x plus 2. And the second equation, negative 18x plus 3y equals 4. And then the second problem would be 3x plus 9y equals 21. And negative x minus 3y equals negative 7. So I would like you to pause this, try those two problems, and you decide whether you want to use substitution or elimination, and then I'll go through them. So we'll do that. Okay, we'll check your answers here. So for the first one, I noticed that there's y by itself. So for me, I would think to use substitution because I already have a variable by itself. You wouldn't have to do that, but you would not be able to use elimination the way that it's set up right now because your equal sign wouldn't be lined up and your x and y are not on the same side as it is here. Whoops. Here. Okay, so you would have to, subtract 6x to the other side with y, and then you could multiply and do some elimination. All right, to me, that's an extra step. If I already have a variable alone, I might as well just plug that in and replace the y in the other equation. So it's ultimately up to you, but most students would probably choose to do substitution here. So negative 18x plus 3 times, in parentheses, 6x plus 2, and then that has to equal 4. I'll distribute, so negative 18x plus 18x and plus 6 equals 4. So this is going to be a unique case here where my x's would cancel out, and I'm left with 6 equals 4. Does 6 equals 4 make sense? No. So this would be a no solution. Okay, so that can happen. There's kind of a similar situation that happens with number 2, but it is not no solution. All right, that would be a common misconception there. So I did set number 2 up thinking that you might do elimination this time because I do have the x's are in line, the y's are in line, your equals are in the same place. It's set up nicely for that. And it's set up nicely for me to just multiply that bottom equation by 3 so I can start to eliminate some variables. Not the only way that you have to do it, but that's my first instinct. So I got 3x plus 9y equals 21. Next, I'd have negative 3x, negative 9y equals negative 21 when I multiply all 3 terms by 3. And then you're going to notice something interesting. When I add these together, this would give me 0, this would give me 0, and this would give me 0. All right, so it's not no solution because 0 does equal 0. That's true. All right, so that means I got a true statement, which is what you have to have happen for an equation. So there are things that satisfy that. We just say there's infinite solutions because there's many, many, many solutions that satisfy it. We do not say all real numbers in this case because all real numbers would mean it could be anything, and it's actually an infinite amount of solutions, but they have to be on those lines. So not every single point would be on those lines. All right, so I just want to kind of summarize real quick what you could have happen in any of these problems that we are working on. There's kind of 3 possibilities here. We can have one solution, and that's the case in our first 3 examples when we were graphing and we did the first substitution and the first elimination answer. We had one solution. That would mean that 2 lines intersect at one point. That's our most typical situation. All right, we just looked at the last 2 where it's possible that there would be no solution. And that will come from when you end up solving it, it doesn't make any sense. your variables cancel out, but you're left with an equation that is not true. That's always going to be your no solution case. Or if I was graphing it, that would mean that you have parallel lines. So the lines are parallel. All right, they'd never intersect. All right, the lines still exist when you have no solution. There's just no point that they share. Okay, it's graphically what is happening. And then the last option that we just saw, the infinite solutions case. That would mean the two lines that you are given are the same. So the lines are the same. Because when you're done, your variables cancel out, but you end with a true statement, something that does make sense. So any point on those lines would satisfy both equations. Okay, so not any point that exists, that would represent all real numbers. It's infinite because the line stretches forever, but only the points within that line. Okay, and that's it for our lesson here. Good luck with your homework. The end.